Alright, so we should be live here. Let's see. Yep, looks like it. Cool, so today just going to do a little live stream. I'm going to mess around with EasyEDA and turn this little circuit here into a circuit board. So we're going to take it from this development board, draw out the schematic, and then hopefully be able to draw out the layout also on the live stream. I'm not an expert in using any of these EDA software, so I'm sure I'll make some mistakes along the way, and I'm sure you guys will call me out in the chat. So yeah, so basically what I'm working on here is just a little solder challenge. It's going to be able to be used as something practical too, but it's pretty much most of the different package sizes you're going to run into working on any of these GM instrument clusters. So obviously everything's through hole on this breadboard here, but once we take it to the circuit board, we're going to make some of it. Some of it's going to be surface mount components too, so that way it's a challenge. I think the most challenging chip that people are going to run into is going to be the Atmega 328. I mean, it is a relatively large pitch on there, but it's still surface mount. So let's take a look at what it does right now with just the current sketch. So plug it in, turn it on. So the backlights are not controlled by any logic at all. They just turn on when it has power. This is controlled by logic here. So once the stepper motor is beyond 60%, it turns on the light, and once it goes back under 60, it turns back off. And then it just does that. So it's a pretty simple design here. We're nothing really crazy going on with it right now, but later on you'll be able to do really whatever you want with it. I just made a really quick sketch of it so that way it just walked back and forth with the stepper motor. But you could very easily put this in with a serial connection and then use it as an actual gauge cluster. So my plan for it is to make them as little individual pods that just have a little SPI out on it, so that way then you can have like multiple ones of them, control them all with one more. You need another Arduino like this to control it. Just talk to it through SPI and give it the values to run on it. So pretty simple design. Just to get it going. So I've already kind of sketched out what I'm going to do with everything for it. So for the stepper driver, we're just using a L293D, which is it's just an H bridge. I believe this is actually it's not actually a D, but it's one of them. So yeah, so we got our H bridge to drive it. With the H bridge, you can actually go up to 12 volts. That way you can run it at a faster speed. But I find you can still go a little bit faster than it's going right now. It's plenty fast enough, so I'm just going to run it at 5 volts. But yeah, if you start going too fast, if you're like over like 100 steps per cycle, it will start to bind up. But you just up the voltage on it. So to do that. For the voltage regulator, I have everything else on there. So let me just adjust the camera real quick so that way y'all can look at my ugly mug while I play on the software here. But yeah, it's going to be a pretty simple design. All that we have to do to get the Atmega up is give it all of its VCCs grounds. We need to put a 1K ohm resistor to the reset, so that way we can still pull reset down to ground to do the in-circuit programming. I'm just gonna put a little ISP header on there basically to program the blank Atmegas that'll be going on there. At first I was gonna do a crystal oscillator that you had to put the capacitors in, and I was like, screw that. I'm just gonna do the little ones that are the package. Everything's in it. It's just a little surface mount. So that'll add a little bit more challenge to the soldering challenge. portion of this board. So like I said, this whole design is really to make a fun project for, you know, guys that work on instrument clusters to, you know, challenge themselves to learn a little bit about programming microcontrollers, because I know a lot of the guys that do this, you know, they always go, oh, how do you do that? It's really easy. So we're gonna put that in there, so that way there's that challenge. You're gonna learn how to program an AVR microcontroller and put your own code on it. So you'll put the bootloader, and then you can just use it like a regular Arduino after that. Oh, so that reminds me, I also need to, because you're going to use it as a regular Arduino, need to have the header for doing your you're gonna need the TXRX and reset also over here. So we will add those too. So let me draw that real quick. Almost forgot about that. I'm glad we were talking about programming it like a regular Arduino, because we need for basically all what you need to do these, because the Arduinos don't actually support USB natively, so you always use a little USB to UART conversion to do it. Unlike the STM32s, where they actually support it natively, you don't have a. See, the STM32 supports USB natively, so there's no FTDI. Like, that's like an FTDI 232 RL, most likely. It's not marked on this because it's a cheap clone, but this is probably a clone of a FTDI 232. The STM32s, they don't need that for their USB connection. Although you don't program these through USB, you program them through UART also. So, but you just or you could use the ST link and do it through like JTAG and SWD and all of that. So yeah, so we do need to add a header there. So let me find my pen or marker or something, just draw that too, so I don't forget to do it on the final one. So we just need this and come down. I'm just drawing it really ugly and fast, that way I don't forget. Come down and just do TX and RX right here. And RX. That's just so I don't forget, because you need TX, RX, and reset for programming it too. Once you put, so you need SPI to put the bootloader on it, and once you put the bootloader on it, then you just come in and UART to it every time you want to reprogram it. It pulls it down into reset, and then it just TX, RX in, and that's it. So it's pretty easy to program one of these once you get it from blank. So let's switch over there. Let's switch the camera over. I need to switch it to where I can see too. So let me pull up EasyEDA, and we're just going to turn this that way y'all can look at my ugly mug while I'm working. All right, I'm going to be upside down here for a second because I flipped the camera. See, that's a kind of crappy angle. Let's go up some more. All right. Yeah, that'll work. Cool. All right, so let's switch over. Okay, so getting started with EasyEDA, all what you have to do is you jump into EasyEDA and create a new project. So this one I'm just labeling it Solder Challenge. By the way, I haven't made any more progress on this one. I know I've talked about it on the channel before, but this is really all the progress I've made on this project. This one is taking the VFD out of the 03 to 07 clusters and making a little Arduino module out of it. But yeah, that one's not going well. So let's get back into this. So we can close that window. Okay. So I made basically a little BOM right here of all the components I'm going to use. Before doing this video, I went into to EasyEDA and verified that you can find them all in the place and pick kind of section there. That's the hardest part I find with any of these EDA softwares is if there's not already a footprint for whatever component you want. I find it difficult to create footprints, which is why that other project, the OKI project, is what I labeled it, because that's the VFD driver on there. I haven't made any progress on is because I need to make a footprint for that VFD and for that OKI chip. So I just haven't taken the time to do that. But yeah, so all of these components are what I'm gonna actually use on there, except for the LEDs. I just grabbed one that EasyEDA had that was that 3528 package size, but I'm not planning on actually using those particular LEDs on it. But everything else, it's what we need. We got our crystal oscillator and Atmega and all that. So let's just go ahead and get started. We're gonna make the schematic first, and then going to make the thing. So let me just look over here and see if we got anything going on in the chat. Nope, no chat. All right, so yeah, let's start dropping some components in here. All right, so let's. I mean, that is the crystal oscillator we're going to use, but let's just start with the Atmega. We'll start there. Search. So this is all what you have to do to find a component in EasyEDA if you've never used it before. So we're going to place that, and of course, it's going to take up most of our sheet here. We might have to do 2 sheets with this. We'll see. So let's just go ahead and put that there. Let's see here. Let's just start placing all of our components we need, and then we can see if we're going to be able to fit them all on one sheet or if we're going to need 2 sheets here. So we'll just get everything involved in the Arduino on here and see if it all fits. Oh, it looks so tiny in comparison. All right. Hopefully this isn't. I hope this isn't one of those like grain or rice sized ones that I picked there. I didn't check. This one might be really challenging for people to solder on, but I mean the whole point of the board is to challenge you to do a little bit better soldering and to teach you something new. So if it's one of the little tiny ones, it's one of the little tiny ones. That's what we'll go with. All right, and let's see. We'll just get the one little resistor we need for that. Not a ton of components on this, though. A lot of these projects can end up with a lot, but all right. So there we go. We'll just shove all of that in that corner there for now, and we'll move it around in a minute. All right, let's get the rest of these on here. We'll start with finding that motor on there. Alright, that one, the drill code doesn't look right. Let me grab one. I guess they weren't sure which side was which, so they put the drill code on both sides of it. Really should only have the drill code on one side. Yeah, it should be like that one. Really don't care too much, though. Let's see. These are all created by members, it looks like. Let me see. Let's see here. Yeah, these are all created. So these are not made by a manufacturer. These are just made by somebody that uses the program. All right, well, let's just place that one. All right, motor driver, and then we'll just start from the top there. All right. Oh God, there's so many of them. Let's go. All right, so let's go to Mauser real quick and get an actual part number for that. I guess there's too many choices there. Let's get a full part number on it. Because yeah. Yep, this is what I'm using, but okay, I guess we don't get a longer part number there. We'll just have to look for the one by ST Microelectronics. All right. Oh, come on, what? User. Whatever. We'll just use this one. Why did they make it like that? They made it so weird. Whatever. Let's look at some of the other ones. There we go. That one's more logical how they drew it. We'll go with that one instead. And we're gonna have to, yeah. So this looks like the pinout is correct because the grounds are in the middle. V motor's there. V chip is no stuff on this side. So yeah, this one looks like it is correct. So we'll go with that one instead of that other one. That other one that wasn't logical because they're not square. It didn't make sense how they drew it out. All right, place symbol. Now we'll just start going through these. Luckily, these are all manufacturer part numbers, so most of them should actually be from the manufacturer. All right, one of those. Let's check the chats here. Still no chat. Okay. Oh well. If you guys don't want to talk, you guys don't want to talk, I guess. But that was really the point of jumping on here, doing a live stream, to talk to you guys while I do this. All right, place symbol. Wrong one. That's what I wanted. I'm just dropping everything in, then I'll organize it all in a more logical, kind of keeping it close to where it needs to be, but not exactly. Alright, we'll put that one over there because that one's going to get the red LED with it. Or sorry, no, the 100 ohm goes with the 3 white LEDs. Like I said, I'm using the same part number for them. Alright, let me do this one too. Just put resistor with resistor. Alright. As you can see, I have drawn some before. I really just don't like making my own footprints. Alright. So yeah, this one just says this is just a random green LED that I grabbed. Alright, so I need 3 of them with this one. And I'm going to need 1 of them down there. Alright. And then, no problem. Voltage regulator we're going to use. This voltage regulator is super overkill for this project. This one's good to like 1.5 amps, if I was not mistaken on it, but we're only using like 10 milliamps. Or sorry, 100 milliamps for the whole project. Yeah, 100 milliamps. Alright. Our voltage regulator. Alright. And then that one has just a little bit of... yeah, that's everything. Cool. Alright, so these capacitors go with the voltage regulator. Like V in got the 1 UF and 4.7 got the voltage out, if I'm not mistaken. And that doesn't look right. That doesn't look like that's drawn correctly. Let me pull up the data sheet on that. Oh, wrong one. Dang it, I'm at work. Catching you while you're at work instead. This one's supposed to be a good learning experience for you guys. All right, so we're gonna pull this up on Mouser. We're gonna look at the data sheet real quick because I think they had the pins wrong on that. So oh no, they had it right. It's ground, V out, and V in. Okay, cool. Normally with these things, ground is in the middle. So okay, whatever. I just want to make sure that was correct before going on. Always verify that stuff when you're drawing these out. Pull up your data sheets and verify it. So if you're wondering how I knew what capacitors to use, I have no idea. I just used the data sheet. So VN, yeah, VN's the one UF to ground and that. So here we'll go draw this out real quick. I mean, we have it pulled up. We might as well draw it. So, yes, let's rotate this. Space gives you a rotate there. Let's rotate that. And so we want one UF with in and 4 with out. Alright, let's see. Come on, let's find a logical way to draw this. Alright, let's see here. Let's verify that is correct. 1 UF on in. Yep, 1 UF on in. This one's just somebody else's drawing of one of these. I pulled it up so that way I could get a better idea of what I'm doing. Okay, so we're just gonna go that, yeah, 4.7's on out. Oh god, I messed it up. Alright, let's try again. Alright. In. And then ground. And one more to ground, and then we can just go like this. Yep. Oh, that's an ugly, but whatever. All right, cool. So there we go. Now we have that, and then this all we need for the logic of it. Yes, we're gonna have a pad to bring in our 12 volts, and we're gonna have a pad for our ground, but we can just throw that in later. So now we have our 5 volt. This creates our 5 volt rail here. But yeah, VN will have a pad, and 12 volts are going to be going into there. This voltage regulator is pretty forgiving. You can go up to like 18 volts on it, and it's still going to put out 5 volts. So, so yeah, that's pretty nice and forgiving there. So, since there's no logic involved in these guys, let's just move them down there and draw them there. All right, let's see here. Where's the little hand tool? I just need to do that. That's right. All right. Oh, I pulled down 4 of them. I only need 3. Crap. Hate when that happens. All right. So then, now that one's not straight. Need another ground. All right, and am I gonna be lazy or am I gonna draw? I'll draw it. I won't do net flags. I won't be that lazy. I want to do a net flag and be lazy, but I'm not going to. Oh, crap. All right, there we go. So that is our backlight circuit. Super simple. It's just that. Nothing else to it. All right. So let's bring this guy down, and we'll set it up over here. We'll just move it around. Oh, crap. Because again, this is just this layout here. It doesn't even apply at all to what we're doing. Alright, so we need 5 volt. Let me pull up my paper here so I don't mess it up though. Alright. Let's draw ground to each of those. Alright. And that's that. So there we go. We got our grounds on there. Voltage for the motors is going to just go straight there. Alright. And see, we had another 5 volt in too, didn't we? V chip, right? 5 volts at 16. 16 and 1. Yeah, 16 and 1. Okay, so that is powers that. Now we need to do our outputs to it. So 4 and 3 will go to 14 and 11, and then same with 1, 2. Just go over there. So cool. Let's move this guy just to make this easier to draw. Okay. Output. No, don't lock to the other ones. Ah, crap, did I? Alright, output. Yep, nice and simple. Output. We're getting lost here. Okay. So there we go. Now we got our motor drawn. Let's see if y'all are screaming at me. Tell me I'm doing something wrong. There we go. I'm glad. I'm Brandon. I'm glad that I inspired you. And it shouldn't be. Let's see. I can pop this out. How do I do this? Pop out live chat. There we go. There we go. Now I can just put that over in this corner, and I don't have to come back to the screen. All right. Oh, but now I lost it. Where'd it go? There we go. All right. So let's see here. Let's drag that out. And oh, look at that. There we go. Cool. Now let's put this over here. Ah. There we go. Okay. 3 and 4 outputs. 3 and 4. Alright, so 1 went to output 1, 4 went to output 4. No, they, oh, yeah, you're correct. They are backwards. It'll work either way. It actually doesn't make a difference, but they are backwards, so we're going to make them right. But, yeah, alright, let's see. Let's just control Z out of that. Yeah, you are correct. Okay, output 3. And output 4. Cool. That, oh crap. And that one I completely missed it. Alright. Alright, there we go. Cool. Yeah. It'll work either way, but let's make it right, right? Okay, so that finished. That's the rest of the motor. Now we need to start doing the IC logic over here. Because this just ties directly to those pins. So we got to do the IC logic and move the IC around and get it all situated. All right, so let's see here. Let me look at my. So I printed out the pin out of the IC and just kind of sketched on here real quick. So let me just get this going. Kind of figure out. Oh, this one's not a good. Let me see if there's another one of this chip, like of this on here, because that's a crappy way of doing it too. Because this is showing it as if it's the DIP 16 in my head. I like my schematics to show things in the order that they are. I hate it when they're like this. Let me see if I can find a different one on there. All right, let's see. Place. I gotta full screen this again to get to that. All right, place symbol. I just hate when the logic for it on here is different than the actual chip. Let's see if we can find another one. Search. All right, let's see. It looks like I'm not going to find one that's laid out the way I want it to be. Oh, well, that's fine. Cancel. Right click. Okay. I will deal with it. I'll be an adult and deal with it. So one thing you're going to notice, normally with this IC, in pretty much any of them that have a like an ADC kind of thing going on there, where it can do like analog and read stuff, you want to tie your AREF and your AVCC separate from all your digital stuff, so that way it doesn't get noise from it and all that. It's supposed to have its own thing going on. I'm not using any ADC on this layout or anything like that, so AREF and AVCC are just going to be tied into VCC also. And for people that aren't familiar with schematics and stuff, that are just automotive technicians here, VCC is going to be your 5-volt rail on this. I mean, VCC does not translate to 5-volt rail all the time. This chip will actually run at 3.3 volts too, so we could have done 3.3 if we wanted. But yeah, so we're doing 5 volts, so VCC is 5 volts on here, and then this one's got ground on here, which is nice. Sometimes they'll do like VDD and like other ones too, but this one's just labeled ground, so it's a little easier to read. But yeah, let's draw this out now. We'll do the lights logic first, just because that's the easiest one. Or should I? Let me just do all my grounds and do my other stuff too. All right. Looks like we just have 1 ground on this side and 2 on that side of that. This looks like it's a crappy place to put it. Let's move those guys and move it over there. There we go. It looks like that gives me the most room to work with on here. Unfull screen this, that way I can see the chat again. Sorry, I suck at Windows. I'm not a computer guy. Alright, I know there's a way to make this thing do this stuff. Alright. So, alright, let's see here. Ground. I'll just move you right there, in between those two. And yeah, normally you'd put some capacitors in between your ground and your stuff, but I'm lazy. This is just a solder challenge. This isn't something that's going to be like in production. I'm not an engineer. I'm not going to design this stuff, right? What do you guys expect out of me? Perfection? Okay. Ground. See, where's the oscillator circuit on here? It should be labeled like X. What's the label for it? XTAL. XTAL, where are you? Ah, there we are. XTAL. Alright. So, this guy is our crystal oscillator. 16 megahertz. So this guy's gonna go. Crap. Let's see here. We'll bring it down from the top instead. Alright, and then you just go to ground also. There we go. Looks kind of stupid, but it works. Whatever. So that's our crystal oscillator on there. Alright, the 1K goes from VCC to the reset pin. Reset is just labeled reset. Alright, cool. I'm guessing reset's up here. Yeah. Alright, what's the number? Pin 29. Pin 29. There we go. There's pin 29. Alright, so if you're wondering how I'm rotating these, I just hit the space bar. So space bar rotates. Alright. Because, I mean, really, you guys should be able to draw. That's the whole point of teaching, like, regular technicians, this kind of stuff, is so that way, when you have an idea for a circuit board, you see, this isn't impossible. You know, this software is free. EasyEDA is absolutely free. It's make an account with them, and JLPCB owns them, so, like, they're going to try to get you to buy your PCB through JLPCB, which has perfectly good deals on them. I normally work with NextPCB just because they've sponsored me on a couple of videos before, which is what I'm going to try to do is get them to sponsor me to make this PCB again. But I can't reach out to them about sponsorship while I'm doing it in EasyEDA because then they'll ask me to do it in KiCad, and I suck at KiCad. It's just not like the stuff doesn't make sense in my head doing it. I don't like it. Plus, I almost always have to draw out everything in that, like, because I don't want to pay the big money for the libraries of all the different components and stuff. So, yeah, NextPCB works with UT source for components. So, and for their CAD, they're like KiCad. They go, it's like KiCad sponsored or whatever, but KiCad's just open source software. They're not actually sponsoring them. I don't think they're sponsoring them. But okay. So I think they labeled okay. So VCC. What is this? Yeah, so AVCC and AREF are the analog stuff. These two just get tied together. So we'll just tie those two together, and then they go to 5 volts. So we'll tie this into that, because we're going to tie that to 5 volts also. And then these two get tied together down here. And we'll just bring that out. And we'll connect to it later. We'll just remember that that's 5 volts. Okay. So let's get our pins. Let's just do those real quick. The pins to the motor. So, alright. It's going to be D2 through D3, which these are not going to be labeled that. Nope, they're not labeled that on here. So that is, let's just get these, let's write these down next to them. Alright. So there we go. D. Alright. D2 is pin 32. 32. And then That makes a lot of sense. All right, 32 and then 1 and 2. All right, 32, 3. Yeah, 3 is pin 1, pin 2, and then where's 5? Where the hell did 5 go? D5 is pin 9. All right. Let's see here. All right, is everything running smooth here? Let's just look over real quick. Live stream's still running. Cool. All right. All right. Y'all haven't all run away, surprisingly, because this is an incredibly boring thing to do a video on, but I don't know. I wanted to do one. All right. So pin 32 is 1, correct? That's what I said. Yeah, D2. So D2 goes to 2, correct? Yep. D2 goes to input 1. 32 is going to be up there. All right. I think I can change the color of these wires. I'll do that some other time, though. All right. 2 is going to go to 1. I'm going to have to delete that. All right. And then, let's see here. 3 goes to pin, so 3 on here, which would be, that's 11, right? 11, no, 10, yeah, 10 is the third one. Yep, cool. So yeah, I'll input 3 pin 10. God, it's written right there. Why do I even look at the paper? It's right there. All right. Where am I going with this? 10 is going to pin 2. All right, and then 4. So the last one for that should be going to pin 9, right? Is that what it was? Yeah, pin 9. Yeah, pin 9's down here. All right, cool. So now this is complete. Oh crap! Control C. I hate when that happens. Okay, let's do this. All right, now we can come down and do that. There we go. Cool. Now, so now the motor's all hooked up. So the motor will work. The backlight's going to work because there's no logic to it. And then we have the idiot light. That's what I call them. I call them idiot lights. Let's see. We'll move this. See, idiot light goes to pin 6. Well, D6. D6 is pin 10. So pin 10's down there on the bottom. So we'll just move this down here. All right. Resistor. I always put the resistor on the ground side of LEDs. I don't know. What's the right way? Is it ground or is it? All right. So there we go. Let's rotate that. That way it's just makes it take less room. Cool. All right. I could have rotated that whole thing so that way I wouldn't have to run the wire this way. All the engineers in here are probably like, what the hell are you doing, dude? You're doing this all the hard way. Let's snake it around this way. My OCD, I'm not OCD at all, actually. I just want it to be easier to look at. There we go, cool. Crap. That didn't do what I wanted it to do. It didn't go over first. I meant to do that. And there we go. Cool. So now the LED, now the idiot light will work too. So everything that we're going to control with the Arduino is going to work. Now, let's see. I don't think there's anything I need to add. I think, yep. Cool. So yeah, there's nothing I really need to add on the schematic portion here. We are going to have pads, just pads for. I'm just going to do plain pads. I'm not going to put a header there. But normally you would just do like a little header, but I'm just going to do little pads that you solder to for it, just because I don't know where this project's going to end afterwards, but for now it's that. So now we're done. We're done drawing the schematic. The schematic of it is complete. Well, no, we didn't do 5 volts. We didn't put our VCC in yet. All right, so let's just bring VCC down there. No, don't get stuck on stuff. Let's see. Yeah, that's a good way to get to it. Cool. So now we have VCC down here, and we just need to bring it up there also. We'll just go from here. And we want our VCC on this side of that resistor. We don't want it on that side, because if we're on that side, then we have 5 volts all the time over here. So we want the 1K. So that way if we, when we pull reset down, it doesn't pull the entire 5 volt rail down and just make the whole thing dead. Okay, so AREF 19. What is 19? Okay, that's just A6. That's an analog pin. Cool. So yeah, now we're done wiring up the microcontroller, everything. This microcontroller will power up. This motor controller is all wired up. Lights are good, and our voltage regulator's got its capacitors and all of that going on with it. So we got ground to all of our grounds, and we have VCC to all of our VCCs, because just verify again. 1. Yeah, that looks correct. 1, 2 VCCs, 1 a VCC, and then yeah, cool. So that is done. All right, so let's save this. Control save. Save to existing project. Solder challenge. Save. There you go. Okay, so now we need to convert. Oh, somebody texted me. Let me see. Or was it? Oh, it's just an email. Never mind. Cool. All right. So, yep, that's done now. Let's convert to PCB. So, convert to PCB. There are some unfinished nets. Do you want to finish nets? Yeah, no. Okay, we'll just skip that. I don't know what I'm doing here. Let's see. I've never had much success with the convert. No, let's just keep going. All right, let's see what happens. Oh, cool. Yeah, there we go. Oh, how big do I want to make this PCB? I didn't think about this. I do want to go with a circle. All right, and I wonder if everything will fit if I do this. Let me grab my calipers just to get a reference of real life what I want here. And let's see. Yeah, this cup is a good size for it. Let's get an idea of how big that is. That's in inches. I want it in millimeters. Metric. That's almost 100. See, that's a little bit big. Try to get an idea how I didn't think about this. This is the one thing I forgot to plan out was how big do I want to make this circuit board? Because that was the whole reason why I went with the Arduino Nano instead of the Uno. I was gonna do this because it'd be a whole lot easier for people to solder in, but it was gonna make it huge, huge. It's gonna be a bigly circuit board. All right, let's try like 50. Let's take a look at what 50 looks like. 50 millimeters. Let's see. So I kind of wanted a similar size. So 60. Two layer, and we'll go with 70. Apply. Alright, well, yeah, everything will fit on there. Cool. Alright, so we're going to put the motor dead center. So let's see here. Control Z. I want you centered. I want you in the center of this damn thing. 0. 0. Alright. That way I can put you dead center also. 0. And 0. Alright. So yeah. Let's bring this down to 60. Let's see 50. Let's look at 50. Let's see if we can make everything fit on here on 50. Alright. So let's look at the logic of these. Alright, so these are the backlight LEDs, so we're just going to put them in a circle around it. Or I guess a triangle would be the correct word. So we're going to put you as a whole. The Y 0. You're going to go on X 0. And who's the next one for you? Alright, and you will go to 0 also. Alright, now, see, so we'll just go with like minus 25 here. Minus 25 here. Oh, well, plus 25. Let's go with minus. Actually, because I'm going to I'll put the idiot light down below it somewhere, so we will put that up positive, so that way it can't wash out the idiot light. Alright, and you will be, want the whole thing. You are X25. There we go, cool. So now we have our LEDs laid out. We probably standard should be a little bit more than 25. Let's just go with 30. $30. Okay. Alright. You're the idiot light, so those would normally be, let's make sure I'm working on the top side. Yeah, I'm working on the top layer. Cool. Alright. Voltage regulator, I'm probably going to move that to the bottom of the PCB anyways. Definitely going to put microcontroller's going to go on the bottom. I think I'll actually stick this up top here. I don't know. Should I? Yeah, I'm gonna put that on the top. All right. One hour of work left to do. All right. Well, go. Yeah, you go get your work done. Don't get fired. Boss will be mad at you if he catches you playing around on YouTube while you're at work. All right. Let's see here. So, voltage regulator, I'll stick it over here. We have voltage regulator, the capacitors that are related to. Oh man, I hate when that happens. I hate when you don't grab the whole thing. And there's a child screaming bloody murder out there. Alright. And C2. There's gotta be a way to like. There we go. Those next to each other. It doesn't have to be perfect. Alright, resistor below it. Alright, oscillator is going to go on the same side as the... Alright, so now how do I move these down to the next layer? I can't remember. Ah, there we go, bottom layer. Bottom layer. Alright, so now let's make you... Alright. Oops, wrong one. Top silk screen. There we go. That just moves that stuff out of me having to look at it. Alright. We'll put... I don't want the noise from the voltage regulator causing any issues, so we'll move you over here. And same with the oscillator. So what are you guys doing right now? What are y'all doing other than watching me? Yeah, y'all got any projects going on? This is the whole point of this. Little chat and doing this. So all these little funky little blue lines you see, those are the nets for it, so that way it can do the automatic where it'll connect, make the wires for me. The trace generation, which I'm going to use that. Okay, well, that's laying out all the components. Do I want to put my header on the top? On standby. Oh, standby. That sounds exciting. I think I want to put all of my stuff. So I put the crystal oscillator like over in this corner. That way it's away from the motor and away from the voltage regulator and all that. So that way it doesn't have any issues. Let's go ahead and add some pads. Let's go back. We're going to do these on the bottom layer, yeah. These pads are going to go on the bottom layer. Oops. I want to make them about that size. How big is that pad of that? Oh, I'm on the wrong one. Let me get back to make everything visible. Alright, that pad, the dimensions of it, 3.5 by 2.2. Okay. Yeah, those are going to be about the dimensions I use. And I'm going to put it on the bottom of the circuit board. Okay. What am I doing? Pad. Alright. I'm going to just do two of them over here for power. So just one there, and move it a little over. All right, there we go. And we're gonna go with square or rectangle, whatever. And yeah, Jeff, that is going to happen sooner than later on the 99 to kind of '07 stuff that's on, not on CAM, but the GM Class 2. We've sniffed all the signals for doing uh, like the test signals, and we can just send them out with one of these super cheap, like $5. This one's like the BAFX products Bluetooth dongle here. You just go into it and do serial over Bluetooth and just start sending the commands. And so you could do your sweep test and everything with one of these. So no longer need the giant box. You just need this in a computer. And you can do it. You don't have to have the cheap ones. You can use, if you already own like a better Bluetooth or USB dongle like this, or just one of those Elm 32 or 321s or whatever. I can't remember. One of those Elm ones. It you can just send the signals out on that. You think Devious for doing all of the Devious and oh, what's his name? He's the guy that did my logo. Campbell is his last name. I can't remember his first name. But Campbell, he sniffed all the stuff. He gave us all of the different signals for it. He posted on PCM hacking and stuff how to do that too after he sniffed it. So the information's out there. I am going to do a video on doing that with this. It probably can do the Chrysler too. We just need to sniff the signals from it. I don't know. I really don't know anything about LIN bus, and I know very little about CAN bus. So I'm under the impression that the Chrysler uses LIN bus, and I literally just heard of LIN bus 2 days ago. I learned about LIN bus. Here, let me switch. Ooh, let me find it real quick. I'm gonna switch the camera so you're looking at me, so you're not looking at my whole Facebook trying to find this thing. Let's see here. So let me find what I want to find real quick, and show you guys this one. Just because take a little break from designing this thing. I want to take a break. All right. Messages. First, let me see that. All right. Where am I going with this? Messenger. I'll pull up these pictures real quick. There we go. Cool. Okay, let's switch it back now. Yeah, there we go. All right. So these things are how PI clusters turns your 99 to 02. This makes a 99 to 02 work in a what do you call it? The 2000 and so 2003 to 2006 instrument cluster. You can make it work by doing this god awful thing to it. So clearly what he's doing here. So this one's right. Let me grab one of these. I need to look at the inlay to see exactly which ones he's messing with there. I'm wrapped up in the chair. Crap. Their inlays are right behind me. Damn it. There we go. Yeah. So it's oil pressure and battery are the two that he's messing with, because they don't have the signal on there. So yeah, that's oil pressure. Yeah. This is exactly what I thought looking at this. So I haven't got this in person. Somebody else sent me these pictures, but so So this one is getting signal for oil pressure right here, and this thing's just driving an X27 on there. So there's an X27 soldered to it. I'm assuming he cuts the traces that go to the controller. Maybe he's not, but yeah. So he's getting ground. He's just cutting into the board here to get his ground. So that's ground tied right there. This is probably 12 volts. Maybe it's 5 volts. Again, I haven't had this in person, so I can't actually like tell you exactly what's going on here. So these look like, I'm almost certain these are coming out of autometer gauges because they do the white circuit boards in them, and other people don't. But other people have told me they think he's getting these custom made. He paid like an engineer to design this, and this is a custom made board. I don't know. Like I said, I haven't had my hands directly on one. I I don't really think it's custom made because it's not. If it was custom made, I would expect to see an AVR chip, so like this Arduino chip that we're working with in my video that we're doing right now, or a STM32 kind of chip on there. And he's not using those to. It's not an STM32, and it's not a an AVR chip on there. So here is the wrong direction. Here is the microcontroller he's using. So it's an ST8S003F3P6 or whatever. I looked it up the other day. That's where it was a couple days ago when I looked this up. That's where I learned about the LIN bus on there, is because this supports LIN bus. So that's the only reason why I even know what LIN bus was from reading the data sheet on this. Because I was trying to figure out, like, what the hell he's doing here. This is stupid. This is the dumbest way to do this. All right, so he's got to, like, chop up the circuit board to do this to it, when the only reason why he has to do this is because these two messages aren't on the bus for so 99 to 02s, the oil pressure is an analog signal going to it. It's not coming through the class 2 bus. And same with the voltage. It just reads the voltage going on in the cluster. So it's not getting that message from the BCM. So oil pressure on the 03 and up, oil pressure comes from the PCM and voltage comes from the BCM. And so he's just manually making this happen inside the cluster, when all is what he'd need to do, because if you're going to hire someone to do this, what you're going to do, pay them, get a little development board, and make it create the signals for it. Oh, that's all what you got to do. You're missing those two signals on the bus, add them to the bus. These things can read voltage, so you can do your voltage measurement with your whatever microcontroller you're using, and that can add it to the bus. And then you need to just run one wire to it for your oil pressure, and then it can read the sending unit too. So this is like taking a sledgehammer to make this happen. This is the difficult way of doing it. I never would have thought to do this. Like, people were like, "Oh, hey, I figured out how he's doing it," and it's these pictures. Like, what the hell is he doing? He's using a sledgehammer when. Okay, all right. I'd lost signal there for a second. All right, yeah. Lost signal there for a second. Sorry about that. But yeah. So this is like this is using a sledgehammer to do something that you do with like a rubber mallet. Maybe not even a rubber mallet. Maybe just a screwdriver. You like use a sledgehammer to drive a screw in. You just need a screwdriver. But I mean, I guess it does work, especially if you're going to charge somebody $800 to do that. But yeah, it's an interesting way of doing it, because yeah, this one's just voltage, so all it needs is ground and voltage, and it just knows what it's doing there. And this other one is oil pressure, so it needs that signal wire in there. Let's go back, find some more pictures. So yeah, that's the microcontroller. But yeah, and then just they put some white duct tape or something on there to keep it from shorting out against the board when he puts them on there. And see, anything else interesting about them? Yeah, that's just getting a ground plane there. I can't tell for a fact that he's actually cutting the. Oh, it looks like he lifts the pads off instead of cutting the trace. He just pulls the whole pad off. Oh yeah, and these are just some other similar products that this person found. But yeah, okay, so you can look, and it looks like this is probably how it's getting programmed. I'm guessing is how they're programming it, and this is just your different signals and stuff that can go to it. So like S is going to be because we saw S was for the oil pressure because the blue wire is going to S on that one. Yeah, that goes to S. So yeah, I mean, hey, it works. It gets the job done. It's an interesting way of doing it. This part number, I couldn't find anything based on that. And this is a date code, 2020-0605. That's a date code. I did check, though, just to make sure. But yeah, nothing came up on either of these. So it's interesting. It's yeah, definitely an interesting way of doing it. This one's designed the same way as the one we're doing in EasyEDA right now. Like, see, take a look. 1, 2, 3. So these circles with an X on it, that's drill code. So that's what you drill code pad. The yellow is silk screen. So yeah, that's all what's going on there. Yeah, I don't know. It's a neat way of doing it. I'm definitely not hating on it. I definitely think it's kind of neat. So yeah, interesting way of achieving. It's just definitely like. Let me make this happen instead of like let's gently just put the signals on the line and it'll work. Oh well. Oh well. All right. So yeah, okay, we're done with this data sheet so yeah, this is that voltage regulator telling you yeah. So we have a guaranteed output of 1.2 amps, and there's different ones, but this one you go all the way up to 18 volts, and it's not going to give us any problems. So this is just going to give us our nice clean 5 volts that we want. So pretty simple little design here. So that's done. But yeah, this is the part. So yeah, minimum input voltage of 2.5 and maximum of 18, and it's gonna output us 5 volts. And so there we go. I'm happy with that. Totally. This is another bringing a sledgehammer in. We don't need this big of a voltage regulator, but at 48 cents, might as well go a little overkill with it. All right. Oh no, I lost some viewers when I lost connection. Oh well. Happens. Alright, done with this one. That's just his schematic. This is that the oscillator that we're using. So this one, nice thing about this oscillator, it has all of the capacitors, everything already in it. So it's just a nice little package there. And then that's that H bridge that we're using to drive it. So yeah, this one you give it all the way down 4.5 volts, go all the way up to 36 volts. Like I said, so like if you wanted to drive these faster, we could totally on. Let's go back to the schematic here. Solder challenge. All right, so pin 8. Oh crap! I just saw that. That's not supposed to be like that. Oh well. We'll have to just fix that one when it draws out. Let me fix it now. Let's go ahead and save that for now. Alright, let's fix this net right here that we got. Alright, Control Z. Stop it. Stop it. Delete. Alright, this one. Delete. Okay. Control Z. Alright. I accidentally got that one stuck on 8. Alright. And you are the first one. Alright, let's make sure we didn't get it stuck on anything else this time. There we go, cool. Alright, so yeah. V8, or sorry, V motors or 8 is where you can add more voltage to it. So you could, this one, instead of, if we wanted this at 12 volts, instead of going to the output right here, we could just come to this input right here and just put 12 volts directly into it. And then you can drive this motor even harder, but 5 volts is more than enough for what we're doing, because we're not making a race car here. We're just It just needs to move. And it still moves good, so it's not like it's slow or anything. GM's just using 5 volts on them, if I'm not mistaken. I'd have to double check, but I think GM's just using 5 volts to run the motor. Yeah, let's get back to this. So let's save this, and then, oops, and then we can update PCB with this, if I'm not mistaken. Okay. Let's not do that yet. Okay. So we need to do this. Finish here. So we left off here. I think it was, we were going to go with a width of like 2.5 and a height of 5. And hole diameter. What is the diameter of this wire? Let me just figure that out real quick. Kind of wire that I normally use. I just don't remember what kind of wire it is to... Where is it? Alright. 1.3 should work. Let's go 1.4, oversize it a little bit there. Okay, cool. Do the same thing here. These are for our 5 volts and... sorry, 12 volts in. Oh, let's go back and look at it. You might be correct. Let me look. Let me fix this before I get distracted, though. So we said width of 2.5 and a height of 5. And we're going with a rectangle. 2.5. Alright, and we went with 1.4. Okay, let me go back to that. Alright, control save. Alright, so the question was, is input 1 and motor controller shorted? Input 1 and... Yes, V-chip and input 1 are, in fact, shorted there. Good catch. So look at that. Like I said when I started the video, I'm going to make mistakes. I'm glad you guys got eagle eyes in here catching this stuff. Making my life a whole lot easier. Alright. Alright, so... Where's input 1 go? It goes to... Alright. See, I was rushing too when I got there. I was like, I gotta get done with this. This is taking forever, and then start making mistakes. All right, and 32. Let me verify that 32 is the correct pin. Yep, 32 is D2. All right. Control save. Let's see. Are there any more mistakes like that before we switch back? All right. Ground's supposed to be shorted. V-chip and V-chip are supposed to be... V-chip... so I didn't use V-chip at all down there when I drew this out. I don't know if... I'm probably supposed to put power to V-chip 9 here. Let me go look at the data sheet for this. I think I already closed... No, I didn't. Alright. Let's look at it in the suggested usage here. See? H-bridge, swing H-bridge. What? What? This is showing a dip 20. It should be a dip 16. Okay. Different pack. Okay, cool. Alright. Suggested usage, or do they don't have one. They don't have a suggested diagram for it. No. I don't know. It works perfectly fine without something there. Yeah, just okay. Whatever. I'm not going to add something to it that I didn't do on the breadboard, It worked on the breadboard like that, so we're gonna just continue on with it. It's probably supposed to have voltage there, but it worked just fine. Okay. I'm not seeing any other shorts. Sorry, it's just glancing over to see if I shorted any of these other ones. Those are supposed to be. Those are supposed to be. Cool, yeah. I don't see any more. I can't type. I'm so tired. I give up. Thanks for that. Oh, God. I can't type. That's embarrassing. And that's recorded there, too. See, normally I don't have this on the recorded screen, so you don't see me, my dyslexic ass, trying to type. Alright. Let's see here. Okay, back to this. Alright, so let's just... we're editing on the wrong layer. So these guys are, yeah, they're multi-layer, so it doesn't matter. Okay. Text. No, I want it on top silk screen. Top silk screen. Text. There we go. Let's go with... Alright. Oh, crap. I wanted to do a net. Connect pad to pad. How do I do the nets in here? Because that's a track. I want to do a net. Text, text, text. Oh, I forget how to do it in here. Maybe I should have added the pads on the other one. I guess just connect pad to pad. Yeah, there we go. Alright. So ground is going to be... Alright. Let me go back and look at the data sheet for this. I can't remember it off the top of my head. Alright, let's pull this data sheet back up. Voltage regulator, where are you? There you are. See, I closed that because I thought I was done with it, but I was not. Alright, pin 1's ground, and VN's pin 3. Alright, and ground was, there we go. Okay, cool. Who's messaging me now? I heard my phone ding. Okay. Alright, one sec. Now ground is on the more logical side. It'll be easier for it to do the auto trace for it. Alright. Let's see here. Alright. So now we have our 12 volts. Now let's do the rest of them. We need to put some pads up here for doing, we need to do our in-circuit programming pads up here. So we'll just do them like right about here on the, let's see, let's take a look here. Alright, so yeah, let's add some pads. I need, how many pads do I need? I need 1, 2, 3, 4, 5, 6, 7. 7 of them. Alright. It should fit that. 1, 2. See, there's a way to do this. Let's see. There's a way to space them away from each other, the same amount every time. Oh, I forgot. I can't remember. Oh well. They won't be perfect. We'll just end up with so we're at 3. Because I'm not putting a header on here, I'm just soldering directly to them, so it's really not too important. 1, 2, 3, 4, 5, 6, 7. I know there's a way to do it, I just can't remember it. So that way it'll make sure they're snapped to the same line and up and down. Because you have to do it when you make the footprints for them. You do it in the footprint when you make them. I just can't remember it off the top of my head. By the way, if y'all are wondering what this EasyEDA tutorial is that I've pulled up, it is how to do a ground plane, how to pour copper on the board, because I'd never had to do it before, so that's why that's opened up. Because I'm gonna have to, you have to put a ground plane underneath your oscillator just to shield it from noise. So I'm gonna have to do at least a ground plane there. Probably just do a ground plane everywhere on this whole thing though. Okay, so there we go. That is our ISP header. So we'll start with putting I'm just going to put one label for all of them. I'm going to do because I'm lazy. Alright. I'm going to put this on the bottom silk screen now. Well, make it not invisible. There we go. Alright. Bottom silk screen. No, I'll do it on the top. I'm going to do it on the top because it's easier for me to think. Because I have to invert it all and just do it on the top layer. Bottom. Top silk screen. Alright. So we're going to go RX, TX. TX. RST. MO. MI. SS. And G. Oh, look at that. They even kind of line up nicely. We'll scoot all of these to fit where they should really be underneath the letters there. Alright, good. G is ground. Slave select, chip select, whatever you want to call it. And honestly, we can break it down like that too, because TX and RX is not going to be used when these are being used. These are for programming, burning our bootloader onto here, and then we can also use it to control this whole thing as a slave on a system if we want to run like 4 or 5 of these at one time, like just make like a whole gauge cluster out of these little circuit boards. Totally possible with that. We're gonna do it SPI, and the only reason why I'm doing it over SPI is because that's the only network that I'm familiar with. I can do I2C, I can do UART, and I can do SPI. I like SPI, so that's how I'll end up doing it. If I knew how to do CAN bus on an Arduino, I would do CAN bus, but I don't know how to do it. So, all right, these are gonna go wire into that now. So let's see. Well, ground doesn't go to that. We'll do connect pad to pad. You just go to ground. All right. And then all the rest of these go to that microcontroller. Okay. And then we'll be done. After that, it's done. This is all that's left. Making these pins on here, and then generating the traces. So we are almost done with this. Let's see. I got the chip here. Let's see. That's the orientation of it. All right. So pin 16 and 15 will be these two. Let's move this puppy back up onto the top layer just for running these wires, and then I'll switch it back down to the bottom. Easier for me to orient. There we go. Okay, and then I will flip it back down there. RX and TX are pin 30 and 31. So those two. So 30 is RX. Oops, I did not hit that. Okay. Right, that's pad to pad, right? Yeah, connect pad to pad. So we're doing RX right now. RX is 30. Alright. And so that makes TX 31. Oh crap, I did a trace. Pad to pad. Alright, reset. Reset needs to go on that side of that resistor. Where is the reset resistor? What R is the reset resistor? That's R1. We need to be. Oh no, we just go to the reset side of it. Yeah, that's right. We don't need to be on this side. If we go on this side of the resistor, we'll pull the whole 5-volt rail down. If we need to be on this side, so I can just go straight to the reset pin. All right. All right, reset. And reset pin is 29. All right. Master out, slave in. Mosey is 15, pin 15. God, I did trace again. And then I tried to do it again. All right, 15. To Mosey. Meso should be 16. That's all there is to doing this. This is easy. This is easy stuff. All right, and then slave select should be like 13, right? Slave select is. We're missing one because we need clock. That's clock. That's not slave select. Hey, we need one more pad. Alright, so clock is, I shorted myself on when I drew this. I'm going to have to add that, unless it may not use slave select to do this. It may just use the reset when it's programming it. Let me look into this real quick. Alright, let me get this to the right pin though. 17. Oh crap. Alright. 17. Alright. Yeah, because then I can't use it. I can't use it as a slave on there. Because yeah, that's clock. Make sure I'm not going crazy. Alright. You just look at it real quick and make sure I remember here. All right. So, yeah, we need slave select. We need it at least for later use. I don't need it for the other one. All right. So, it's 10. 10 is what it normally uses. Is 10 being used for anything? 10. D10. Where's D10? Right, it's labeled 10 for that. Yeah. Oh, this one doesn't even have D10 listed on here. It's got 13. Ah, there it is. I found it. 10 is 14. Is 14 being used for anything? God, stop moving. There we go. 14. Okay, cool. We do have that available. I guess we'll just squeeze that in right there. Whoops. Alright, let's just scoot this stuff over. Use a little hand tool. We'll just squeeze you in right there. Add a pad. That is not slave select. That is clock. I'm just going to put a C for clock. And you go over a little bit. Just put 1S for slave select. That way it doesn't push it over too much. Okay, we're getting a little bit close on all of that, so let's scoot all this down. Again, we can get away with these big stupid pads like this because, you know, not perfect. I'll clean it up before I send it in to get manufactured, but this gets it done for the video. So that's all there is to this. We're done now. That's everything. I could generate the traces, but I'm gonna move this. Let's actually move all of these to at least the same line. So, let's see, Y. Let's go with like 3.3, and then just copy that, and we'll just put those all at least they're even. Alright, let's move you back over to the bottom of the board. It moves everything around a little bit, but that's pretty much it. Let's make sure this updated. It did not update those net labels there. You can see those are all still shorted together like they were. Or no. Is it? Yeah, those are all shorted together. I'll have to fix that. So it didn't update the labels after we fixed them on here. Alright. Update PCB. There we go. Apply changes. There we go. That should fix them. And didn't delete those. Cool. Alright. There's a set of align buttons on the toolbar. Well, let's see. I do actually have to go here soon, though. But yeah, let's see. There's a fabrication. Below fabrication in the toolbar. Oh, okay, so it's over here. So it's some of the stuff that's grayed out. I've done this before. It's just been like months, so I don't remember. And I don't get on here too often. Let's see, vertical alignment, horizontal alignment. Okay. Okay. Yeah. So what do I do? Just go like select all of these and then I can do, I mean, they're already aligned, but let's do this just so that way if I do it again, I will remember how to do it every time. Cool. So that would horizontally align them if they were not. Does this space them? Ah, there we go. Ha ha ha. Done. There we go. Sweet. Look at that. Now it's nice and evenly spaced out because, like, yeah, this is kind of a crappy way of putting my silk screen on there, but whatever. So, just out of curiosity, if I move it, yeah, that's what I thought would happen. back to the top. We'll just leave it on the top. Oh, not there. I don't want it in the top copper. I want it in the top silk screen. There we go. Cool. Cool, cool, cool. All right, so yeah, we have voltage now. We have all of those. Okay, let's generate the auto route. Yeah. Well, track width. I'm assuming that's in millimeters, so then I can. I pulled it up earlier. Do I still have it pulled up? I use a calculator every time because I can never remember. All right, let's see. Calculator. All right. Let's see. I'm just going to go with the maximum of this whole circuit board because I've already tested it out before. It pulls like 0.15 amps. So there we go. So our required trace width is 1.2. It's actually a really thick trace. And I'm just going to go with it for the whole thing, even though it only needs like 1.2 in like a couple of spots. All right, run. Okay, and then this is just gonna run. It's gonna do it. It'll do it, but it does. Since it's on the cloud, it's gonna do it whenever it feels like doing it. I really should have downloaded the driver for it. I don't have it installed on here right now. I have it installed on my other computer, the one I normally do this stuff on, because this one's out in the office. When I normally draw circuit boards and stuff in the house instead. But let me check that. I think my wife is texting me, telling me that she needs some information. Alright. So... Apparently you have more experience with EasyEDA than I do, Brandon. Like I don't know. I just don't do it a lot. I probably shouldn't have put U3 so close to the edge there. I'm pretty guilty of that. Yeah, oh, I forgot to do the stop. We don't, because we need to do see. So copper area. Yeah, net ground. Alright, so let's see here. We need to go, we're going to work on the bottom layer. Oops, not make it invisible. Work on the bottom layer. Never even heard of it. Well, that's embarrassing. Oh, this is not. I'm not liking this. Oh God, I don't like this. Is there a way to just auto route like the whole thing? Let's look at the tutorial real quick. I pulled this up because I really don't know how to do this, and I meant to read it before doing the thing. Okay, yeah, that's. Oh, can I just do the whole? Yeah, just do the whole damn thing. Because yeah, it should route around it. Cool. I'll just do the whole damn back of this thing as a copper pour. Oh, but it's like a square and it's not round. Oh, let's see. Can I make it round? Let's see. Let's just see what it does. Oh, that didn't do anything. All right. I wish there was a way to make it round so I could just do the whole damn board. I'm just messing with it right now, trying to make one. All right, and then can I make this? Oh yeah, this isn't working. Yeah, I know best practice is definitely to make a uh, thing. I'll just do it on the top. No, it'll look stupid. Huh. I don't know what I'm doing here. Let's scroll through this. They make it look so easy in that picture. Like, yeah, it just works. Look at this crap. Like, that's not easy. This should be like Microsoft Paint, where I can just use a bucket, just pour it. I mean, it's even called like a copper pour. Okay, with a copper pour. Let's see. Let's do a Google of this. Copper possum, what? Pour. There's got to be a way to just like. Okay, so it sounds like I do this after I make the traces. Okay. So, doing this out of order now. Let's go make the traces and then do this. All right. Let's save everything. Save our changes to it. All right. I didn't delete your comment. It probably got flagged by YouTube. It probably automatically deleted it. Yeah, because I definitely did not delete your comment. I've had somebody else ask me that before too on a, oops, on a, what was it? Now I'm curious. All right. But yeah, anything that's, I also do have it set up to automatically not in the live chat with it. Right before I lost signal. Oh, maybe it's because I lost signal and the stream was just technically dead. It also could have been it. Because it'll like pause the stream, so if you've sent it while the stream was down, YouTube will stop the stream for a second, so. Oh, shoot, I'm getting tired. My wife's blowing up my phone. She wants some information from me. Trying to get insurance for the kids. She got the information she needed from me then. Alright. Oh yeah, now I remember what I was going to do. I'm like, what the hell am I trying to do? Trying to install the stupid thing. See. I have to reboot the computer though. Alright. Route. Auto route. Alright. Install. Yes, EasyEDA. Spy on my computer. Come on, where's it? I just want to install it. I've done this before. There we go. Ah, network error. What? Network error. I'm probably using up all my bandwidth doing the live stream. I'm not going to be able to download it. Okay. Alright, I'm not just not going to be able to do that. We'll have to do it on the cloud, which means we have to wait till it's convenient for them. Alright. So, yeah. Damn, I hate waiting on the cloud for this. They should have a feature on here. They should have a check mark on here to pour copper. Like it should be just like real time display. Okay, pour copper. Run. All right. So now we just gotta wait for whenever it's convenient for them to route this. Ah, yes. It started immediately this time. And sometimes it'll get stuck. Like if it's impossible, at least when you local host it'll get stuck sometimes if it's impossible. This may not be possible with that track width. I might have to go a little bit smaller on the track width. I think I'm definitely going to have to go smaller on the track width. I think that's what's taking so... Let's just cancel it. Let's cancel it. We're gonna go smaller. I know IPC guidance was to no, we're not going with a larger board. I want to keep this thing small. Oh, I forgot to put drill code in it too. Oh no, it's still doing it. Stop. Where did I do auto route? All right, cancel. Okay. Like, cool. IPC guidance says we have to do it this way. We'll survive. It's not gonna catch on fire. All right. Let's do this. Yeah, of course I designed my own circuit boards. I suck at it. As you can tell, we're like 2 hours into a stream of me trying to do this. But yes, I've done a couple of circuit boards now. All right. Yeah, run. Oh, cancel. It's not stopping auto route. Stop route. Okay. There was a way to make it delete them all too. Because there's just no way it was going to be. There was no way it was going to be able to do all of these. I mean, it's wider than the pad width, so like that. There was just no way that was going to work. Stop route. Let's see. I can't control Z out of that too. There's a way to do it. Where was it? Route. Oh, unroute all. There we go. Now we can auto route with the smaller track width. So 0.9. Let's just go with how wide are the... And then after I auto route it, the only ones I'm going to up are the outputs of the voltage regulator, because most of that current's really going to the LEDs anyways, the LEDs and this. So I just up the route from the voltage regulator to the motor and that. So yeah, the trace at least. Okay, so how wide are these? Width 0.45. Okay, so we'll just auto route it to around that, and then we'll up the track width on the ones that need to be. Okay. This will be much easier for it to route, and then I can clean it up. But yeah, no, I don't want that big of a circuit board. Hey, so that circuit board's currently going to be what do we set it to? 60 or 70? So let's see, give you an idea there. Right there. I mean, that's great. That's just barely bigger than the motor. I like it. I like it. It's not too much bigger than the motor. I think it was 60. I already forgot. Oh, come on. Now it auto routes. Somebody else is routing something, so I have to wait, I guess. Or they're like, you bastard, you unrouted it. Oh, LED 3 got moved there. Move that back. Just trying to picture that. Yeah, that chip's much shorter than the motor there. There we go. Now we're routing. What? Why'd you go there? Running vias. Wow, they're really going close to the edge there. A lot of the manufacturers don't like that. They get mad at you. Like, eh, don't do that. I don't have anything exciting to say while I'm waiting on it to auto route. We're just waiting on things to happen now. We're watching paint dry, guys. See, this would be if I had like a sponsor. This would be like the perfect time to like plug my sponsor. It'd be like yeah, you guys are my sponsor. Let start dropping some super chats, and I'll, I'll yeah. Don't super chat, please don't. I'll feel like I have to put in better content for you guys if y'all start dropping super chats. Which flux did you order? Did you go with Chip Quick or did you go with the MG Chemicals? I like the MG Chemicals because it's cheap, but the Chip Quick is slightly better. Um, the Chip Quick's just like $5 more, so I don't know. Almost done, 82%. We're almost done there. Look at that. Look at that. This thing looks professional now. Look at all these like traces going places and doing things. Yeah, the Chip Quick's good stuff. I like it. I really do like the SMD 291. That's my favorite. Hey, I'm glad. I'm glad you enjoy the channel, Revamp. Yeah, that's the whole point of it is to really just share the knowledge, teach what we know to each other. Hopefully you're part of the Facebook group. I know it's hard for me to keep track of everybody that's in it. But yeah, the Facebook group. Here, let me pull it up real quick. I'm gonna switch the camera again so y'all aren't looking at my whole Facebook. Let's see. switch it back. Screen and HDMI. There you go. So yeah, this is the Facebook group right here. But I'll drop the link in the chat here. There we go. That's the Facebook group. It's not like my channel Facebook group kind of thing. It's just a group for everybody. I did like totally go like, I'm gonna do a live stream. Because I don't know, I hadn't been getting a ton of views in my live stream, so I was like, let me try to get some more people in here. But this group is for you guys to you know, come and join the group, and there you go. See, look, you got approved. Um, so yeah, just join the group and ask questions. People post, they'll post bins in there. We have a file section in the group, so that way we have like, uh, guys are posting it, so you can see, Garrett's a great guy and has shared a lot. There you go. That Matt guy's pretty cool, whoever he is, and Mike's pretty cool. Um, and so these are like, here's you a um, thing, here's your pinout to that. So pretty cool stuff. People in here sharing really useful information with everybody. So definitely, I think the Facebook group is a asset that you should be joining if you have Facebook. Router timed out. Oh no. No, it didn't finish. Yeah, we have some nets that are not done. Probably because I changed pages. It's like, you can't do that. You have to stay and watch. Let's see. Let me just look at. Yeah, cool. I still have that set up right. But whatever. Okay. Auto route. It'll pick up where it left off, though. Luckily. I don't have a local auto route. It just has a couple, so this should be pretty quick now for the rest of them. I'm sure it timed out because I changed screens, so they're like, you can't do that. You have to watch us do this. But like I said earlier, EasyEDA, it's free to use, so like if you ever have an idea for a circuit board, just try. You'll never get anything done if you don't try. While this is doing it, hopefully it doesn't time out again. So here's my very first one that I ever did. Let's see. That's the square one. This is the first circuit board I ever drew out, which all is what it was. Let's see. I think I still got those things sitting around. I had them out because I was thinking about using them in this project. I don't see them. Oh, here they are. Yeah, because I was gonna try to use them as project. So these are little 12-volt RGB lights that you can control. So that's all what this is. You used to not be able to buy like a little pixel of them, so I drew this out, and that was it. So that was my first circuit board that I ever did. I never actually put the capacitor on there. There's supposed to be a 1 UF capacitor, but these have a built-in capacitor, so they'll survive without it. So that was it, and it just passes ground, and then has it so that way you can put these in series. Just have a whole bunch of them. Then this is my second one I ever designed, which is the Eprom Programmer. And the design's out there for anybody that wants to use it. Still, this project's kind of dead though because with the this new cheaper thing. So let's see, is this still running or did I cancel it? Probably canceled again. All right. Where's? No, it's just not running it. Okay. And you don't have to use auto route. You can hand draw out all of these things. I just choose not to. It's so obvious when you do auto route too, because I'll do like, boo. You can change the settings to do curves instead of straight lines and stuff like that. Electrons might fall off at hard angles. No, they won't. There's a lot of guys that say you can't do 90-degree angles on circuit boards, but You can do 90-degree angles. The electrons are not going to just fall off the pad or the trace. It's not going to happen. Are you even routing? Okay, that's just the chat window there. See, how many people are watching still? How many people are watching the paint dry on this auto route process? Let's see here. There it is. Oh, we got 7 people. 7 people are watching the paint dry. Yeah. Yeah, I really don't have anything else super interesting to talk about. Oh man, now I'm hitting the microphone. Um, this had to have crashed. Let's try one more time. Route auto router. Hey, my phone's dinging. All right, but yeah, so these we'll talk about these things. What are they? So it's a WS2815 is the part number for these. These are the 12-volt equivalent of those same lights you see. What's his channel's name? It's like Jeff Myers or something like that. Let me see here. Let's look him up. Let's see. Oh, hey, look, I'm live streaming. Huh, who would have ever guessed? What's his channel name? I think it's Jeff Myers. Is it Jeff Myers? No. Let's see. God, I'm not subscribed to his channel, but let's see. RGB LED. Oh, come on. What was his name? Jack? Is it Jack Myers? Misspelling his last name. Yeah, there you go. That's him. Yeah. So he has this older video that he did. Let's go through his videos. By the way, I like his channel. I think it's a cool channel. But I'm just not. I so happen to not be subscribed to him. Not because. All right. So yeah, this one. I even commented on the video, but yeah, he used the 5-volt ones. I have some of them. I have some of those too. So this is the 5-volt equivalent of this. So yeah, these are just run at 12 volts. So like in his, you had to use resistors and all that with it. Or no, he used a buck converter, if I remember right. So he just used a buck converter to drop it down to 5 volts. Instead of, you could just use these. They'll run at 12 volts, and they don't really have issues at 14 volts. They're rated to 12, but I used them in my truck for a whole year and didn't have any problems. So, yeah, they work. So these ones, 12-volt equivalent, the same thing. So that's what I was just trying to achieve in that, was doing that, but at 12 volts instead of 5 volts. That way you didn't need the buck converter. He even forgot to show the buck converter in the video, I think. But yeah, still, I like his channel. I think it's a cool channel. So definitely not knocking him, saying that he doesn't know what he's doing or anything. He does. I mean, first of all, this was 2 years ago when he did the video. These came out like a year and a half ago. So I don't think, or these may have come out 2 years ago. So these were brand new at the time when he did the video. So it was just one of those luck of the draw that I even found that these existed to do it. So, okay, question. Let me get back to this. That way, hopefully it doesn't time out on me again. Why are you not routing? Why? Is it because it's not saved? I don't know. I don't know why it's not routing. We may have to end the video on... Oh, look, and it's not only not routing. It's saying those are not within clearance either. I might have to move this chip before I can get it to route. That may be why it's not routing, is because it can't. All right, let's move this. Yeah, look at how this is gonna screw that up. All right, let's unroute everything. All right, let's move you because you're on the bottom, so you can be a little bit closer to that, and then let's give you a little more clearance too from because you are shorter than the whole thing anyways. All right. And since I noticed that earlier, we'll scoot you in a little bit too. Now let's try auto routing. We might have to rotate some stuff, but we will try auto routing it there. That's probably why it wasn't. It's because it was just stuck. All right. Also save it. Is there a trick to getting the bulbs unsoldered from the Chevy HVAC without... Alright, so those stupid HVAC boards are really cheaply made with way too small vias, and it is really hard to get the LEDs, or the original bulbs out. What I always do is use plenty of flux before I try to get it off. I then come in with my desolder gun and try to take it off. If that doesn't work, I will use low temperature solder. Leaded solder will work. I have low temperature solder, so I use low temperature solder. So I have this Chip Quick low temperature solder. And what it looks like. It's the non-bismuth based low temperature solder. You don't want to use any bismuth based low temperature solder if you use leaded solder, which we all use leaded solder. So the bismuth based, when it mixes with lead, it becomes like 70 or 80 degrees Celsius melting point. So it comes really low to where in like regular operation it could do it, and you'll leave behind contaminant. So you don't want to use any of the bismuth based low temperature solders if you use leaded solder, because it just leaves you at a greater risk of you're going to have fractured solder joints because you left this stuff behind. This isn't bismuth based. Oh look, it's routing. It's routing. But if you don't want to buy low temperature solder, just mix in some leaded solder into that solder joint, because it still makes an alloy that melts at a lower temperature than that lead-free solder that they used in there. So yeah, flux, and I use low temperature solder. We're gonna look and see if we can find some real quick. All right. Chip Quick. Come on. Oh, it's thinking very slowly. Don't you crash on me. You keep routing. Looks like it's just a couple left. I'm not seeing any yellow X's either, so may have spaced things out nicely. Okay. Chip Quick. All right. Let's see, what do we got for choices here? They have tools? I didn't know they even made tools. Alright, I'm just trying to find that solder for you. Alright, so it's this iron based stuff here. I think this is what I have. I'm pretty sure this is the same stuff I have right here. So this IN52/SN48. This is definitely a low temperature solder. But yeah, this stuff works good. I really like it. Let me see. Am I logged in? I'm not gonna log in. I'd pull up my order history and tell you exactly, like for sure, that this is the one that I have. I'm pretty confident that this is the low temperature seller I have. See, it's kind of expensive. It's $20 for 10 feet of it. So, um, it's it, it's not cheap, but you don't use much of it because it's not like you're soldering with it every day and using it for everything. You're just using it to desolder stuff. Ah, damn it. Quit again. All right, I'm not going to torture y'all to wait and watch me finish routing this. This is done. This is done. So all's what we do once it does route, verify that we have traces to everything, that we didn't make any mistakes with our nets, and then you will go to fabrication, and or is it tools? Where's how do I export it? I mean, if we're gonna order with SN48, yeah, the IN52 SN48 right here. That's ChipQuick's part number for it. That way you can just copy and paste it. Should come up on DigiKey also. DigiKey. Yep, DigiKey carries it also. So if you don't like ordering from Moza, you have DigiKey. So yep, you got options there. You don't have to shop with the guy I shop with. I rarely order from DigiKey. I mean, clearly I order from him. I have an account, but it's just not as often. All right. Okay. Yeah, it couldn't finish it. 15 of them wouldn't work. All right, so I'll have to shift some stuff around. It's probably here that I need to do it. Um, let's see, these two. So it couldn't run a trace for that one. Why couldn't it do it on the top? All right, I could do that. All right, so this is bottom layer. So top layer, run a trace here, do a via down. Then, or that's all bottom layer. That's all on the bottom layer. So I go to there. So we're trying to get to the idiot light. So it's just the one. So down, up top, come around up top, come over here, and then yeah. So come to here and go to there. So we're on the top layer. So we need to do a via here, go down, and come here, and then come back to the top. Do another via here and back up top. Look at that. That wasn't hard. That one's done. uh, I'll fight with this to run the rest off camera though. But let's go into how to order this now. Once we're done, let's just pretend like we're done. So we're gonna go File, Export, and export the generate PCB fabrication, not export. So you just click this, and okay, yeah, you gotta save it. You click that, and it's saying that I'm not done, which they're correct. I'm not done, and you would just click yes if it was done, and then it's gonna prompt you before it lets you do it. So let's just say, is it gonna do? Okay, so and see, look, it's going to prompt you like, yeah, order it with JLPCB, because, I mean, hey, look, they have good deals. Let's say we want 100 of them, and we want black, and we just want it served, and we're going to go with 1 ounce copper. $5 for 10 of them. That's a pretty good deal. So, yeah, like, you could definitely order it to that, or you can click Generate Gerber. So then you just click Generate Gerber, and you can send it to whatever manufacturer you want. Let's see, so yeah, JLPCB, they do a good job. I've ordered from them before, and Next PCB, they do a good job too. I've ordered from them, and they've sponsored me before. So obviously, I have a bias towards Next PCB because they've sponsored me before, but yeah, they're both definitely good options. So I'm gonna end the live stream here because this is really everything you need to know about doing this. And yeah, that's really it. So I hope you guys liked the video. I hope you liked the live stream, I guess, and I hope you learned something. And I'll see you guys in the next one.